This represents a roof truss, and this represents the bottom chord of roof truss, and this is the top plate of the upper story wall. The connection that we're going to be improving is this one. This once again represents the bottom chord of the roof truss. These two are the top plate of the upper wall. And normally when the builder places the roof truss on the top plate of the wall, they put in 3 nails, here, here, and here. Those are called toe nails. And according to the building code, once they do that, they're done. But this is not a very strong connection. What I'm going to do is demonstrate how to put in this $1 truss screw. With my labor, it's going to come to about $1.80, right up into the roof to wall connection. So I've got a specimen up here. There's my specimen. That goes in there. Latch it down. Take the truss screw and the special bit that comes with it. Place it underneath the connection. All right. Take that out of there. And there's the connection. This is an engine hoist, and we've modified it slightly so that it can hold down the bottom of this. It can hold the bottom of this test specimen. We've modified it with this. There's a steel channel down here at the bottom here, and it's got these straps connected to that channel. So here's the specimen without the truss screw in it, just the 3 toenails. All right, so now we start loading up the connection by pumping on the hydraulic jack, and you can see the load here in kilograms. All right, so now we've got 80, 100, 130, 160 kilograms, and that's about all we're going to get out of this, about 160 kilograms. And then it fractures. 160 kilograms, you multiply by about 2.2, so about 160, 320, 350 pounds of uplift capacity of those nails. Now we place in the specimen that has the truss screw in it. All right, so we got about 350 pounds out of the last one. Jack this up. Please always wear safety goggles while doing this. All right, so we're already at above that load. We're at 350 kilograms, 380, 420, 450, 490, 520, 560, 600, 650, 690, 730, 820, 850 kilograms. So that's about a little under 2,000 pounds, much greater strength. So the weak connection would fail somewhere around the beginning of an EF0 tornado hitting the building. The strong one would survive an EF3, maybe something higher. And that's how we do that test. Adding this screw costs about $2 per screw, about $1.80 per screw, and there may be 50 of them in a house. So a couple $100. And that makes a difference. So number one, marginal cost, really quick to install, seconds to install, and it makes the difference between that connection not surviving any kind of tornado hit and it surviving at least an EF3 tornado hit.
Find out more about our research at ICLR.org.